Good morning. I, I. Last night, yesterday, I talked about Australia, and I talked about the morning glory clouds. Morning glory, which is now what I'm looking into, is clouds in Australia. When I came across this paper or this article, why more clouds can mean less rain in Australia. On any given day in Australia, a giant cotton-sized cloud that dumps rain from Broome to Hobart has increased in frequency over the past 33 years. A cloud that just stretches across here repetitively, like it's a thing that just happens, known as Northwest Cloud Band. It's a band of broad, continuous, moisture-laden cloud that stretches from the tropical East Indian Ocean to southern Australia. They have it described as warm and cold, basically, coming together. In the southern hemisphere, both southern Australia is prone to these tropical visitors of low and high pressure systems. When there are tropical visitors, when there are high pressure systems over southwest, western Australia, southwest and Queensland. When there's two high zones here, as this sets up the ideal air flow for northwest cloud bands. So I was wondering when I saw this, is there, like, it's kind of going across, generally from around this corner here to around here. If there's a relationship in this structure that also plays a role, like the shapes, by shaping the land atop the surface to a degree to have certain curvatures that then are conducive of forming a sort of channel. I mean, it's not really. I would expect it to be like, at first guess, I would expect it to go right here, pretty much. So it doesn't do that. Like some slight change in the elevation of the terrain that kind of just brings material down to some channel that it flows through, but that is not where it is. I mean, it looks more like it's from here down here. Let's look at the map. There must be a way to just turn off clouds. As cool as clouds are to have. Kind of here. So there's this system and this system. The two pillars, it goes between the two pillars. And then generally out by this third pillar. I don't know why that would matter. Like right across there. Okay. So I was noticing the reason I found this of interest, especially, is because not only are we noticing them more, like there actually are more of them, of this northwest cloud band. Uh, like since they were satellite era began in 1970s, scientists were particularly interested in the 1980s and 90s. So they're very intrigued of these things then, but they have lost interest in these northwest cloudlands. Cause rainfall in Victoria. Is that Victoria down here? This region? Yeah, okay. Oh. Okay. So, basically, this is a thing that's happening that looks to be increasing in provides 80% of the annual rainfall for northwestern Australia. Southern Australia receives most of its rainfall when the band connects with cold front systems. The band increases rainfall over the northwest, central, and southeastern Australia. The cloud band is an extensive layer of cloud that tends to be 3,000 to 8,000 kilometers long and would link a cold front or cut off lows at their southeastern end to the IT intertropical convergence zone, known as the doldrums or the calms because of the monotonous windless weather. Let's go back. Would link a cold front at their southeastern end to the northwestern end to this region. South Pacific convergence zone would often be connected to a northwest cloud band. Doesn't just show where it is. Polynesia. Simple solution was to create our own updated record. Our research produced a record of northwest cloud bands from 1984 to through 2016. As new satellite data becomes available, we are constantly updating the record. Importantly, the 33-year-old record means we can now observe long-term trends. And we found northwest cloud bands are occurring more often over Australia at a rate of about one extra day per year. In fact, they have nearly doubled in frequency, and we don't really know why. Climate change! There's a raft of possible explanations, all needing further research. Oh, there it is. I didn't even need to. Of course, there wasn't a question. That would be like the fucking go-to. Oh, clearly it's our fault. It's got nothing to do with any terrain in the region. Certainly not. Nothing to do with anything of ammonite structure in the region. Nope. Our fault. You know what? Now I say the Ammonite's boundary is really here. Maybe it's like caught at the boundary of the Ammonite and kind of goes down it. and just kind of flows down this way off of this ammonite. Like it current flowing this way gets forced down around it some reason to a degree where it begins to cause cloud formations that specifically just go like that. Maybe. And you know, the Earth. This process was thousands of years ago when the Earth expanded, not millions, and so it's still changing, and that would be certainly reflected in things of this nature. Impact of drought in Australia. It would be nice to assume that an increase in the frequency of these cloud bands would bring more rain, but in fact, the reverse may be true. You know, I've seen enough landslides because of just saturated land to be like, maybe you guys don't want too much rain. This looks like I can't fathom if this had a bunch of rain weighing on top of it. Like, this is its support structure out here. And then this huge open plate, pretty much. That's just a sheet across that holds form somehow because of proximity to here. I don't really understand how Eastern Australia over here is still stable and didn't already, when the Earth expanded, just kind of like do something more of this nature, causing like more of an Australian boundary over here, like here maybe. Like a miniature Australia. So that's these clouds. Excuse me. Morning glory clouds, and then what causes a morning glory? So I was looking at this, and these form, as I mentioned yesterday, here, and possibly, as I mentioned yesterday, are related to the ammonite structure here, where currents just get kind of stuck in it and flow out this way, or even just generally out this way by this ammonite structure, and just flow into this region, but like as a current flowing this way that's wide and has like a long elongated feature that makes it look more like these. This is the only known location where it can be predicted, but I was looking around trying to find where it tends to happen, because if there's an ammonite here that's causing it, maybe the locations, Central America, which is makes sense because like especially pertaining to this thing, like this has a magnetic field, so there's a lot of potential here in this region, basically in this region, for something to be up with the currents above of the clouds in a way that then lead to like more of an ammonite structure. Let's see if we even see ammonite type features. I never really looked for like a specifically an ammonite rotation, like maybe coming out this way, rotating this way. I don't know. Cape Cod. Where's Cape Cod? Massachusetts. Occasionally reported there, Cape Cod. in the Gulf of California. Sable Island. Sable Island. Here. Here. Pass through here. Newfoundland. Eastern Kimberly. So they've been seen also in the Ammonite over at the other side of the Ammonite. Eastern Kimberly, like flowing maybe this way in this Ammonite structure. Generally having like sideways propagation around it as it like turns. As well as over the Arabian Sea. All of these places are I've talked about Nova Scotia as being a Nova center. Here's Nova Scotia. Here's Massachusetts. There's a Nova center here that would have gone like this way otherwise, but it nova'd outward to create a boundary from colliding currents. I believe one going this way and one going this way. One went this way and basically went into underneath the continent and began to open over here, but then I really think another one went this way from over here. That's spread out this way. And also went down through here and into South America. But then one went this way. Basically, there's a nova here, so maybe because of novas, they are more likely to produce the environmental conditions necessary, because that's pretty much what Australia is just a string of them in a sequential order, like boom, 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 boom. So it just kind of like cups the region to shape the currents a bit to a point where it actually shapes the currents and the clouds, is my guess, obviously. Brazil. Over the bay in Brazil. I guess that does. Let's search for it. I'm not sure where the bay is. Where's the boundary of Brazil? Is it really all the way down here? Holy crap. Holy shit. I had no idea Brazil was pretty much all of South America, half of it. Holy crap, I thought it was more like here. And then there were different countries throughout here. This is huge. Half of the freaking country. Venezuela's up here, Colombia, and everything else got their own little chunk of the... It's like the nucleus and then the outer boundary. Boom. Around the Andes, even, interestingly. Where it's like more tumultuous terrain. It's separated more. But then the more just uniform region without the Andes is just Brazil. Holy crap. Okay, so anyway. Apparently over here, maybe somewhere. Somewhere around here, it's referring to. And maybe if I just click this, it'll at least give me like a dot. Okay. I don't know. Down here, I mean, maybe it's related to just generally currents flowing like this across out here, and then when it runs into water source, humidification type region, it starts to cross the boundary in like a widened current that can produce the morning clouds, morning glory clouds. Indonesia to down to Tasmania. Oh, that's not morning. That's not the morning glory cloud anymore. Brazil happened again over Peregrino Field in South Campos Basin. Let's see if this is kind of in line with the Andes. Peregrino. Oil field offshore east of Rio de Janeiro. So over here. Oh, okay. Yeah, okay. So pretty much in line with this. But that might indicate something like out here. I feel like it's just some kind of boundary of a... Because here there's even a there's certainly a boundary here too. It's not just above ground. Where the current flowed in here and then fanned out. So it kind of produced like a boundary. Basin originated Cretaceous 345 to 130 or 145 to 130 million years ago. Radiometric dating. Just wondering if that was relevant. Some subtle indicator. Phenomenon was also recorded on Batran Shore, Lebanon. September 2004. Atron Shore. Probably there. Is good. Okay. Well, certainly there's an undercurrent that flowed directly this way to shape the region entirely. This way. And maybe that's related. Like it went generally through Persian Gulf and through like here, but also more to like the center of this. And then it hits again moisture at the boundary and produces the clouds at the boundary of the moisture that it's hitting. So I guess when I said that the clouds over Australia flowing around and back to are probably not true, just instead the currents flow this way and just hit the boundary within the ammonite again, but the ammonite encourages the shape for sure. Not sure what, like maybe this region being part of an ammonite itself, really, because Africa is a distinct ammonite shape, but then like it's very close to the point where it's almost like it's dendritically part of the upper back of the ammonite, where there's like dendrites that kind of extend beyond a point in appearance. Durban, South Africa. Ghana coastline, that's a good sign. And again, pretty much is where this, like if we follow this current of generally speaking, the East African Rift, maybe, it comes pretty much to there. So maybe there's just like currents that flow around this ammonite, around here, and then out this way. Generally out here. Enough to have produced a morning glory cloud there. Certainly they're rare, so like that they're even forming in a location is pretty interesting. St. Cloud, Florida. Ruskin, Florida. St. Cloud. Look at it, where these clouds form. It brings me to St. Cloud, Florida. Oh my god. That's an anomalous one. Like what the? Although there is a bunch of moisture here. So it really just needs a cross current running into a bunch of moisture, maybe. Like here's Tampa, and so that's over here probably. Up a bit. Kind of in direction to that. So it's like here. So maybe it's past this feature, plays into it. Like basically a wind blowing this way that ramped up and then fell back down over some like change in the terrain energetically, whatever exactly, where this interacted with it and caused it to ramp up and flow back. But it was also like passing this boundary, generally speaking, which is where we start to really get into the like water. Here, I wonder if there's like a distinct rain boundary in Florida here that tends to be like north, this region, less rain. Ew, a bunch of rain just before it. Just right across it. Like in this region. Like it got caught up there. And in this region, it certainly falls into there. But down here also. Down here. Okay, so what else we got? And then Ruskin, which is pretty much right next to Tampa. So here and over here. Somewhere. So these things can form where I'm at, pretty much. I'm over here. Not to zero in on where I'm at exactly, but across a boundary here, generally speaking, apparently. So maybe they, like, because it's seen there, it already degraded to a point. That's crazy. Like, it's a little odd if it's only seen in this specific town. Morning glory cloud formed over Apelscha, Netherlands. I was gonna say it's not near water, but okay, there we go. Maybe that same current flowing out this way, flows up this way, flows up this way, generally goes up this way. Generally up this way. Is that it? Here's the Arabian Peninsula here. So here is Lebanon. Here's this current flowing out this way, and then actually going this way because it was not open yet. So it was actually going straight at the time, so it went this way. Out across here. Maybe under here to a degree. Shaping a boundary here, so then I started to go around it. Up to here. So where is this, generally? It's kind of past this head here. Here, so it's here. It really is pretty much in this current, plus on top of that, it's like kind of where a mound exists in front of it though, like over here. So like there's not a mound here underneath the ground, really. Like it's very lacking of material. So the currents are just flowing down it, but then they like ramp up in some way here by resistance and at a water boundary that then maybe is conducive enough to produce at least an observation of it. Richmond, Virginia. That seems... What do you mean you didn't find it? Seems a little too inland, basically. Although it could be related to Appalachians forcing air like away from them generally, like air just flowing downhill off of them that then runs into a boundary of humidity that maybe was further inland. There is pretty good humidity in this region. What time of year was that? February. That seems like not when I would expect it. Not at all. More like that. June over Florida. November in Netherlands. September in Lebanon. August in Brazil, which would be winter. So in the winter in Brazil, May, April. So it doesn't seem that dependent on the time of year, and more so just the circumstances that maybe the time of year like increase the likelihood by just being more humidity or more rain or whatever exactly conditions necessary to increase the likelihood of morning glory clouds. Do we want more images? Really trying to find some images. So it's like rolling forward, but then it's moving forward but rolling back. That's so strange. There's gotta be more cloud images. That's crazy. Yeah, that's real distinct. If you see that moving through the sky, you're like, that's a distinct cloud. I could see why they are named and like, wow. I would like to see that relative to land. Like this. This image seems to show one here, like right off the land, and another here that's like energetically connected still. That has like moved out. It's almost like a polygonal boundary is being formed. So they're generally rolling in kind of sideways. Like down. And this does have features that would perhaps participate in that. And even in like channeling like a bond over here, like it tends to bond right there maybe. Let's see. I guess this one has that. Like this one, both of these clouds go to that region. I wonder if that region does have some like energetic node that these things tend to like form related to. Whoa. Um, there's just gotta be better images. Oh my god. Clouds map. Cloud cover. Maybe Earth. Let's go here. Air. Can I see clouds? I really don't know how to find clouds specifically. There's gotta be. This is the ocean. Chemicals, particulates, space. And whatever bio looks like it is generally airflow. I don't know. Surface winds. Let's just see what kind of winds we get over Australia. This is interesting. I wonder if that's generally there. It's about here to here. About here to here. So like here. Pretty much it's spawning from the storm, the vortex in this general region. A current coming across, a second current coming through here, colliding with it here. This is like pretty much mimicking how these currents were, which is interesting. Let's go to higher elevation. We still kind of see the same, and then a boundary line that begins to be overwhelmed now at this stage where these currents are going this way, reaching out into there. Below, oops, and then reaching out over. Let's see, now just flowing over, really around this ammonite, right around that ammonite. around the Ammonite-ish, and now the Ammonite is really not affecting it substantially. Maybe a little bit is still driving something here, but... And it's as if it's not there. Let's go to a different day. Just go back. Not a full year, because then we need a different time of the year. Let's say month 6. Yeah, okay. Now we got currents just flowing across it. Just across this way. Across it. Some kind of back this way. Change in the currents. Not as distinct of anything current-wise happening here. Whoa. Let's say 9. Sort of a boundary there. Boundary. Nothing especially ammonite-like there either. Little more potential in this one to have some kind of interaction, maybe. Energetic interaction down from the ammonite through up to the clouds and the currents of the winds. Okay, let's go back to today, but then, actually, let's just go back to today real quick. Okay, so this one we seem to have a plausible ammonite type thing directing these currents to a degree. I know it's kind of a stretch in some ways. Which then flows around it here. Like, this is pretty crazy, this one. If it was like this more regularly, I'd be like, wow. But so far, I've only found the present December one. Let's go a year back now. See if it's like dependent on time of year where maybe it tends to have more of an ammonite-like currents here. Like, there's kind of like a flow center here. Again, generally. And then cross currents and losing its shape entirely. Let's go back a year again. Okay. This is forming kind of on the boundary of the ammonite. Okay, so that was a little less exciting. I'm not sure if it's easy enough to do something of that nature, to just be like, oh, and see something clear. I wish, but it seems like wishful thinking, maybe. Only in the very early hours of the morning. Because, like, when the sun's rays come over top the ammonite at an angle, maybe, and cause eddies above. Okay. Um, there does seem to be a relationship. They said best place Burketown. Maybe because Burketown is actually where they hinge themselves energetically. Over right there. Maybe it's related to this then. Like a combination of the two. Current flowing this way and a current flowing this way kind of thing. That mix. Even an undercurrent that just has energies propagating like heat and other things of that nature that then cause cross currents still from below. Oh. Okay, that's what I got for now. See y'all soon.